Okay, fine. Yesterday I think we just got started and took an overview of what is there in the input output related to input output. Fine. Okay, so later we had looked at other things that was related to creating an executable jar. Okay, fine. We have jar files which were so executable jar file could be created. Later from Java 9 we had modularity, in which case there was slight change in what goes, how the jar file is created. From Java 9 there is a module, right, and a module is made up of multiple packages. Okay, so there you are supposed to have one jar file per module. Fine. A module would be packaged into a single jar file. The module may have multiple packages. Fine, but there would be, and name of the module is what the name of the jar file would be normally. So what is your module name? Fine, so you'll have that module name dot jar. Okay, so let's proceed with the java.io package. Fine, so overview of the java.io package. If you look at java.io package, okay, in the java.io package we have got 4 top level stream classes. Fine, we may have output stream, we have an input stream, so this is categorization based on the flow, the direction of the flow. Fine, so flow is, output stream is, the flow is from the application to, fine. So actually it's a stream. When I say output stream or anything, so an object of an output stream is something where you will give the data. Fine. Okay, you should be able to give data to an object of a output stream, which would be in the form of bytes. So you are giving bytes to an output stream. Some binary data is there. Fine. And if it's an input stream, or if it's an input stream, the direction is you fetch data from it. Okay. From input stream you should be able to fetch the data. That's there's an operation called read, and for output stream there's an operation called write. Okay. Fine. Exactly similar thing, only thing, instead of binary data which is dealing with bytes, okay, so this is the direction, right, inward or outward, and the other is about the type of data. So it's a character data. Fine. What flows in the streams is character data. Then we have the concept of we have a writer class and we have a reader class. Okay, so that way we've got 4 top level stream classes. All these 4 are abstract classes. Fine, all the 4 top level stream classes are abstract. Fine, and we have subclasses which are non-abstract to this. We have got a lot of subclasses. Fine. Okay, so if I have an output stream, what does the output stream normally have? The functionality, okay, it's something where I can give data, but ultimately that data has to go somewhere. Okay, so output streams are like some kind of a sink, so they have some destination and ultimately where the data will go. It's a place where your application is able to give data to it. Okay, fine. So you have a method to write to it, but when I write here, what happens to that? Fine, it depends on what kind of output stream I have. Okay, so you may have a kind of an output stream where if you give data, it will go into a file. You may have another kind of an output stream where if you give data, it goes on the network. Fine. How the data is handled is so how the data gets handled is different with different output streams. So you've got different subclasses of the output stream. Okay. Same way, so this have a destination. So there is some destination to it. Okay. And same way, input stream has some kind of it is associated with some kind of a source from where, if you are asking for data, it's going to fetch it from some place and then give it to you. Fine. Your read operation is going to fetch it from some place. So the kind of different type of sources, accordingly you will have different kinds of input streams. Okay. Fine. So various subclasses of input stream. So there are some basic methods which are there in each of those. Fine. Subclasses are there which may enhance the functionality. They may add more methods to it. Fine. There might be more functionality. Okay. Fine. So we'll see that part. Again, now related, there are a few interfaces which are here. There's a common interface for both of these. This side, yes, there is a common interface. These both would implement an interface called flushable. Okay, these two things would implement an interface called flushable. Fine. Something common for all four. All four. See, when I create any object of any of the stream types, okay, input stream, output stream, reader or writer, and they have an associated source or a destination. And they occupy some resources. Fine. I have opened a file for reading. Fine. Okay. So what is necessary is, once the use is over, we need to release those resources. Fine. Creating the object, that's the time. As soon as you create the object, fine, you are basically, if it's I am taking example of a file, fine, you are taking a file handle, fine, there is some system resource you are occupying, fine. So creating object, fine, opens a file, but then we need to close it also, right? So all of them have a common interface called, what is common to all of them? They are all closable. Okay, they are all closable. Closable interface has a method called close. Fine. Used for releasing whatever resource it has taken up. Fine. So normally after a close, no, you won't be able to do a read or write, whatever it is. Okay. So closable is something which is common for all four. These two are flushable. Okay. What is flushable? Associated with this is the method called close. Associated with this is the method called flush. Okay. So what is flush? It's only for when you are giving output. Right. These streams may be using some kind of internal buffers. They may use some internal buffer. Fine. So the idea being that, fine, because they have an associated destination, if you give data to the output stream or a writer, and if you are giving data to the output stream or a writer, no, you don't have to wait. The write method doesn't wait for the data to reach the final destination. It can remain in a buffer here, internal buffer, it can remain. And it may not be a good idea to write only 1 byte to a device at one time. Fine, let there be at least 512 bytes before I actually give the data to the device. And it may be a costly thing to write one byte each time, right? Okay, fine, and therefore they use some kind of an internal buffer. Fine. So the write method finishes fast. Okay, fine, because it has just taken into a buffer, and your write method. Okay, I've done. Fine. The data is, you have given the data to the output stream. Fine, but it has not reached the final destination. Calling flush will ensure that any previous data which you have given to the output stream or the writer has reached its final destination. So calling flush would mean, okay, let me now flush out the buffer to the final destination. If there is anything in the buffer, it will be ensured that they have reached the final destination. Okay, fine. So flush would wait for the data to reach the destination, any previous data. Fine. Buffer. So, see, this is an internal buffer here. Okay, NIO has a buffer which is an object of, which is a Java object, separate Java object. Fine, where the data has to be first populated if you want to write. Okay, and then give it to a channel saying that's a buffer which needs to go out. Fine. Okay, so you deal through a object of buffer basically in case of NIO. That is, buffer is a separate class altogether in NIO. Fine, and lot of operations are available on buffer also. Fine. Here that's internal thing. The buffer I am talking of is a internal buffer, internal to the stream, and each stream may fine, a stream may not even use a buffer. Fine, we may not know about it. Okay, but yes, flush means it has ensured that whatever is the final destination, data has reached there. Okay, fine. So a few related interfaces. Fine. So we have 4 top level classes. We have interfaces like flushable. We have interface called closable. There is also an interface called which is implemented only by the reader. There is an interface called readable. Yeah. This came later, readable interface, and this is mainly related to NIO again. Fine. This is related to NIO. In readable, okay, it's reading into a, yeah, okay, in readable you can read it into a buffer. Fine. With readable you can read it into a buffer. So there is a read method again. Readable is providing read method which is implemented in the reader. Another related interface is for the writer. Okay, there is also an interface which is implemented by writer which is called appendable. We have the interface called appendable. Okay, so these are some related interfaces. A few interfaces, for example, I think the readable interface, the appendable interface, and they are both in the java.lang package. They are part of java.lang. Readable, appendable, they are not in IO. They are java.lang. Appendable is just equivalent of a write. We have a write method. Oh, there is a similar method called append. Write means what? You are giving data. And where does data go in a stream? Always at the end. Fine. Okay. So they said, okay, let's have a append method which is there in appendable also implemented here. Fine. See, we use string class. What is string? It's immutable. Objects of string class are immutable, but there is a mutable version for managing sequence of characters. String buffer, string builder. And we have those two classes which are mutable sequence of characters. And you create the object, but then it could be modified. And you can make modifications in a string buffer or a string builder. Fine. Oh, those are also implementing appendable. Fine. It's a common thing across. Fine. So it might be it's a string buffer or string builder. Yeah, it's like a stream of characters. You can think of it as a made up of characters. Okay, so like a stream of characters, I can just keep on adding more characters into that buffer, string buffer or a string builder. And that's what a writer is. In a writer, you're just pushing more characters into it. You're always appending there. Okay, giving more data. So that's the appendable interface. Right? There's an appendable interface. Fine. So these are okay. So for the top level stream classes, these are some associated interfaces. There are few more interfaces. Some of the there are some subclasses under this. Okay, especially under the output stream and under the input stream. Okay, a few classes which are there. They implement another interface. I'm just listing some interfaces here. We have an interface called data output, and there's another interface called data input. We have the interface called data output and the interface called data input. And data output means, okay, normally if I look at an output stream, and the basic output stream which we have, that abstract class which we have, it has operations to handle a single byte or a byte array or some segment of a byte array. We'll see what those write methods, how it is overloaded. Okay, but then what about primitive types? Oh, it's just byte, single byte or an array of bytes that we want to handle. I have got an int value which is actually 4 bytes, fine, and I might like to put it into a file, 4-byte binary data. Fine. Okay. So what I might be required to do is, oh, that 5 you have got int value, but then you need to convert it into either a byte array or maybe write 4 times, separate out each of those 4 bytes, and then fine, and then only you will be able to give it to a output stream. Fine. So this kind of functionality, adding functionality like this to handle all kinds of primitive values also. Fine, you would be able to write all kinds of primitive types to handle primitive types, and there are some cases for strings also. So there are methods like this which have been specified in the data output. Same way for fetching data which is of primitive type, so binary data available in some file or something, whatever the source may be, and you want to fetch data, you have the methods for reading into various primitive types. That's what the data input is. And so we have interfaces like this. They only take care mainly of the primitive types and string. Fine. But then we have another kind of a problem. We have created some account object which has a name, it has a passbook. The passbook is what is a passbook? It's an array list here. So we have an array list which in turn has a transaction object, a number of transaction objects. See, there's a whole tree of objects. If I just look at account object, or there are a whole tree of, it's a full tree. Fine, it's a, or I'll say network of objects. One object has linked objects. Okay, and there comes a challenge of storing objects. I have this account object and I want this account object to be stored into a file. Why would we store it into a file? Reuse what way? The reuse would be at some other point of time I might like to recreate this object again. So there is a state of the object, fine, you have persistence for it, okay, save it into a file, maybe you exit, and we have that bank clerk which is doing the job of fine opening account and all those things. Bank has so many things, fine, and then when we quit, everything is gone. If those objects which were in memory and all the bank object and all its associated objects, if they were in a file, and when I start next time I find a file, I just load and recreate that same kind of hierarchy for me. The same bank object, if I could recreate by reading from a file the required data. So there is a process which is nothing but a process of persisting an object. You have object data and the entire object, fine, but when we say object, it's not just one, right? It's a whole network of objects. Okay, fine. So this process of converting, and ultimately what is there in a file? File is made up of bytes. So we have a process of converting object into a sequence of bytes, fine, which can be later reused for recreating the object in the same state. So conversion of objects into a sequence of bytes, that process is known as serialization. So objects can be serialized for the purpose of persistence. Okay, fine. So object can be serialized, but not all objects can be serialized. Just like not everything can be cloned. Okay, whatever is implementing a serializable interface, only that's what is going to be, it's allowed to be serialized. And a marker interface. So there is a marker interface called serializable. And we have a marker interface called serializable. Fine. The data output and the data input, they were related to handling primitive types. They were only handling primitive types. We got sub-interfaces, extensions to this. Okay, we will handle primitives as well as we will handle object serialization or object deserialization. Serialization is about storing, that's related to output. So we have what we call as, so we do have another interface called object output, and same way there is an interface here. Its only added functionality is about, this is about object serialization and this is related to object deserialization, which is nothing but another interface called object input. Fine, these fine, I am mainly mentioning the interfaces here, fine. Okay, but there is a class, okay, there is one of the class, I had mentioned about it yesterday also, okay, which is implementing these two things, the data input and the data output. Fine. They are implemented by a class. Let me put it on this side. So there is a class to implement both of these, and that is the class called random access file. Fine. Fine. A class which has methods for output as well as input. And it's not extending any of the stream classes, and it's not an extension of the stream classes. Fine, but it has both functionality, reading as well as writing. Fine. So with a file, we understand we should be able to read and write both. Okay. So there's this class called random access file implementing the two interfaces. Fine. So most of the java.io package is here. And of course, what we have not shown are the subclasses of those four things. We'll be looking at them as we go into those. Fine. But another one more class which is part of the java.io package where we will begin. That's a class called for file management. What's a class? The class called file. Okay, so we begin here. And let's first start with this. Okay. Again, we are looking at the file class. Okay, fine. But you may also refer to, and here we may not cover that, but you should refer to java.nio.file package, where we got an interface called path. Okay, we have got an interface called path. File. Fine. It's known as NIO2. It came from Java 7. And it's referred as NIO2. So if someone is referring NIO2, you should know it's java.nio.file package. Okay. Fine. But let's look at that old thing, the class called file. Yeah. Okay. So yeah, file class. Let's see the constructors for the file class. What does a file object have? It has a abstract path. Fine. Yesterday I think we did start with this and said, okay, we understand two things. There's a file separator and there is a path separator. There's a file separator and a path separator. Okay. So for that, the file class has got two public static final variables, or there are four variables in all. Okay. So there are four public static final variables. Let me put them here. Okay. Public static final. Fine. The type as a string, you've got both types. So there is one called string, and same thing again, the type is char, and two different constants. So we have something called file separator and we have a file separator char. So it would be slash or the backslash thing, right? File separator is the slash or a backslash. Backslash for the windows. Method. No, that's not a method. It's a public static final variable. Constants. These are constants. They didn't follow the convention about constant. If it is a constant, the convention is to write all capitals and separated by underscore. So it should have been capital file underscore separator. Okay, but anyway, that I mean it's the conventions, the standards which have been specified mention this, right? If it's a final variable, it has to be all capitals. Different developers are there. And in the API, once something is done, you can't undo it. You can't undo in the next version. They could actually have added 2 more, the correct ones also. Let them remain for backward compatibility, but the correct ones could have been there, right? Same way, if you have got public static final string, we have something called path separator and path separator char. The type is char. Okay, so first thing, find these 4 constants. Fine. Now coming to the object part. Okay. Fine. The constructor here. So constructor for file, there are various constructors. One constructor says you can have a string to specify an abstract path, and you can create an object of file like this. Or you could also create a file object by specifying a string which is for a path and another string which is relative to this path. You have some more, maybe it's a file name. Okay, so here's a path which represents a directory, and within the directory may be a file name. Fine. So this is additional path relative to a given path. Fine. Now a file object has a path. A file object contains a path, and therefore another constructor which exists is like this. It says instead of as a string, you might use an existing path and give a string relative to that. Fine. So when you create a file object, it is just some path which is available within the object. The object just contains name of a path, and some path on the it may or may not even exist. The path which you have mentioned may not be something which is physically existing also.
So path last one is file path
and file name.
Last one.
String file name. Type is a string. Okay. The kind of methods we have method to return Boolean value, saying exists do we have such a thing? For example, what you might be doing, maybe we save our data into a file with what is the bank name. Fine, our bank data may have been saved into a file. So if it is HDFC, we can give our own extensions also to our files, right? So you can say, oh, HDFC.bank. .bank can be an extension for if we are saving object of bank. Okay, fine, it's our own, fine, you can give any file names. So maybe, so what you might do is, you might say, okay, let me have a new file. So I can say, okay, file, bank file equals new file, create a file object with the name of the bank. Okay, so from command line or from some place you got the bank name. Fine, and then you might say, okay, if bank file dot exists. Okay, if it is existing, I might like to load the data from there. Otherwise, I am going to create a new bank object maybe. I create a bank object by loading from the file, or I create the bank object as a new one, depending on if I find the file. Okay, I'll load from there. If I don't find the file, I'll create a new bank object. And so you might be using something like this, exists, and to know whether this exists or not. Okay, right. See, one thing, it is, when I say path, it would mean either a file or a directory. Fine, whatever path you have given, if it exists, maybe it exists, even you could be checking for a directory whether this directory exists. Okay, if it exists, maybe you would like to know is directory is file. You can find out if it's a directory or it's a file. Bank name. Bank name is a variable where we have taken a name of the bank. If this is over, and then we have a if statement to do a checking. If bank file, that's a file object we created.
Okay,
exists. Fine, using exists to know whether that file exists or not. So if you want to know a particular file exists or not, create a file object for that path and call the exist method. And so file has the exist method, not the string. Okay, fine. There are certain times a method which is common to file and string both. And for example, we have a method to return long. Name of the method is length, and recollect, length is also a method for string. Fine. Here if someone says bank name dot length, then what is it? How many characters in the name of the bank? But if I say bank file dot length, what does it tell me? How many bytes in the file? The number of bytes in the file, the size of the file, file size in bytes. And so we have a method like this, length also. Okay.
So string dot length के बाद तो parenthesis नहीं आता. String dot length.
है ना? Arrays dot length. for array. What you are talking, the number of elements in the array. That is not a method. It's more like a variable.
Array want to initially.
With string, you have to. It's a method. String has a method called length.
The size method किस में? Size.
It is in collection. Size. Size is number of elements in a collection. Array is simply length. Okay. Okay. Fine. Fine. So one is you can check if it exists. You can check if it's a directory or it's a file. And that would be only if it exists. Okay. And you could also check what kind of access you have. Fine. So we have something to return Boolean values. Oops, sorry. We have something to return Boolean values. Okay. Can read. And we can say can write, can execute. Fine. So permissions of read, write, execute on this file, that can be checked.
Can read, can write, can execute.
Yeah. See how you create your file by specifying a path, right? How do you specify the path? Two ways. You specify a absolute path, or you may be specifying relative path. Fine, you might be specifying a relative path relative to your current directory. Fine. See, in case of Linux, if you start with a slash, then you are giving a absolute path. If you start with a slash, right? And the string which you use for creating a file object. So if you start with a slash, that means you are talking about root, you are giving the full path. Okay. If you don't start with a slash, straight away start with some name and slash something, right? Then you are giving a relative path. You can create a file object using either of those kind of things. You might be using an absolute path, you might be using a relative path. Fine. You have a method to return a string. It says get absolute path. If it has been created using a relative things, okay, what's the full path? And you can find the absolute path for it. So it will be prepended with the whatever is your current directory, right? So if you are giving a relative path, it needs to be prepended with your current directory.
Absolute path means a
Full path, which starts with a slash for Linux. And on Windows environment, it might be starting with a drive letter. Fine, C colon and then backslash, or D colon backslash, or something like that. Okay, fine. Now about a file, what information? Another operation you can perform is there's a method to return Boolean again. There's a method called delete. So if it was an existing path, fine, and if it's a directory which is empty, it may get deleted. provided you have those permissions, right? Can read, write, execute, those things. Fine, you have the appropriate permissions. Fine. Or if it's a file, it can be deleted. Fine, file may get deleted. A directory, if it is empty, can be deleted. If the directory is not empty and you are trying to delete, that won't be deleted. Relative. You have an absolute path and you have a relative path.
So relative part में तो current working directory में देखना present working directory.
Yes. Fine, relative to the current directory. Relative means relative to the current directory. If you don't start with a slash, it's relative to the current directory. Fine. In case of Windows, if you don't start with a backslash or you don't start with a drive letter. Okay. Fine. It reminds me of another method, which is a static method, which would be useful for Windows environment. Okay, fine. There is a method which is more useful for the Windows environment. There is a method called it's a static method to return a file array. Name of the method is list roots. What does it return? An array containing the file objects for each of the root directories. In case of Linux, there is only one root, slash. Unix and Linux, you will have only one root. In case of Windows, every drive has a root. Fine, there is a root directory for every drive. So it creates a C:\\, D:\, E:\, fine. Whatever are the drives currently available in your system, for that it will create a file array. So if you want to know what are all the drives available, you can do it like this.
So a last root है या lost root?
List, list, L-I-S-T, list. So root directories, list roots. Fine. Okay, we can get information about the size of the file. We can get info. You have created a full path. Everything was specified. Okay. See, the last part, the last element in your path is a file name. It may be a directory name also because it represents a directory, but just that last element itself. So you have a method called getName to return a string. This is going to give you only the last element in your path, which may be either a file name or a directory name, according to whether this path represents a directory or a file. And basically giving you the last element. Get name, then okay. So you can get the name of a file, just the name part instead of the full path. Then you can know the size. You might like to know the last modification date time. So we have a method called last modified, and it returns long. Long is time in milliseconds. And when we talk of long, time in milliseconds, it's only from Java 8 that we got the java.time package, which has the local date, local time and all those classes.
So to फिर convert करना
This long, you can format it straight. It can be formatted with printf also, long value, or you can use it to create an object of the date class. The java.util package has a date class, which is the old one. See, there are two old classes. Prior to Java 8, there were two classes which were used. In the java.util package, you had a class called date, and we also have a class called calendar. So, yeah, this long value can be used in both of these things. And this is the timeout in milliseconds, time in milliseconds, sorry, for your date. So, last modification, date time, that can be seen. Okay. Now, given a directory, given a path which is representing a directory, you may be interested in knowing the list of files there and getting a directory listing. So, we have 4 different methods. There is a method called list, which would return a string array. So, what is the string array? When this will work only on a file object which represents a directory, not on a file object which is for a file. Okay, fine. For a directory, if I say list, what does it return? A string array. What does the string array contain? Names of the file in that directory, just the names. Okay, but we also have a method called list files to return, instead of as a string array, it returns a file array. What is the difference? In case of a string array, in the case of list, you only get the names. In case of list files, you get a file object, which means you can get any information about the file in that directory. You can work on those, fine, you can carry out some operations on those. Fine, so it creates file objects and give it to you. Okay, methods of both these methods are overloaded. Fine, these are methods you can know, they are right from Java 1.0 and 1.1 onwards.
So इसका use होता है?
अभी तो path आ गया है. Fine, but yes, you might find old code which is still using this. Otherwise, maybe NIO, right? NIO tool. We have fine. So we have the list method to take as parameter file name filter. Fine. And if it's a list, it is returning a string array. We have list files returning a file array, yeah, where you can pass a file name filter. Fine. Only for list file a further overloading is available, where you can pass, instead of a file name filter, you can pass a file filter. and it returns a file array. Yeah, we have two interfaces. These two are interfaces, a file filter and a file name filter. Understand, when this API was there, we didn't have Java 8. We didn't have the Java util function package. We didn't have the predicate. But these are predicates. You'll find, oh, they are actually predicates, not marked as predicate, but they are equivalent of what we have in Java 8, what we have as a predicate. One is a by predicate, other is a predicate. The file name filter is a by predicate and file filter is a predicate. Right. See what a file name filter would do. Just think, this is a by predicate basically. If it's a by predicate and it's returning a string array, what the list method is doing?
Same.
It's returning all those names which pass the predicate. Predicate is a test. This is a test. It's not marked as a predicate. Let me tell you, it's not marked as a predicate. Fine, I'm just using that same term because it's exactly like a predicate. File name filter is a by predicate and file filter is a predicate. Let's see what is there in the file name filter. If I look at this, what's the method in the file name filter? Okay, so in a file name filter, okay, so if I look at a file name filter, when we may use this file name filter, it has a method to return Boolean. Yeah, predicate returns Boolean. Only thing, the name of the method is different. The method in predicate is called test. Here the method name is accept, which takes two parameters. One parameter is a file object for a directory and second parameter is a string for the file name. So it's giving two inputs, a directory and a file in that directory, and you have to just say true or false. Fine. So it's just a function. Fine. This is the interface file name filter with one abstract method. It's a function interface. From Java 8 it has become a function interface. Fine. From Java 8 we have a lambda expression which can be used here. Fine. And other one, the file filter. A file filter interface returns Boolean. Okay, name of the method is accept, but there the parameter is only a file. It's a predicate. That one, earlier one, is a by predicate.
So ये list return क्या करेगा?
List returns names of the files in that directory, but not all the files. Only those files which are returning true here. So whatever is the file, fine, what will be done? The file, the directory from where the files are picked up and their names are separated and then given separately into this, right? In file name filter, the file name has been separated out. In file filter, it's not separated out. It's giving you the file object. Test this and tell me. And so they are both equivalent things. File name filter and file filter. See, if I combine these two, I create a file. You know, we have a constructor where a file and a string can be given to create a new file. So it's that kind of a thing. And it might be more convenient to use file filter rather than the file name filter, and it's going to be more convenient, much better to use a list files instead of just the list, because with list files you get all the information about the file, and with list you only get the names. Fine, I'll just give a small example how we use this filter. Okay, so you want a list of, so you got some directory, and from that directory you want to list all the files whose extension, which have an extension of .java. Fine, so you might be using a file name filter. Fine, if you use a file name filter, so I might say, okay, so let's have a file array, and we have a file array, Java file names, Java files. Let's say Java files equals, for some directory file object which is a directory, and let's say I have a variable called dir which is a file object representing some directory. Okay, dot list files, because list files would return a file array. Fine, I have taken into a file array. If I just use list, I would have to use a string array, and that would be Java file names. Okay, parameter, a filter. So do you want to write a lambda or want to write the old style, the anonymous class? Lambda. Okay, fine. So what would be the lambda? Given two objects, let's say d for dir, fn for file name, yeah, and my lambda would only say fn dot ends with, or we have a string method called ends with, when a string ends with a particular substring, ends with dot java. Done. Given a directory name and a file name, and you return a true or false. So all those things where it is ending in .java, and that's where the true is returned. So only those things will come in that array. Fine. Now someone says, oh, I want small files. Small files means files whose size is less than 1K. I want all those files whose size is less than 1K. How do we go about it? File array, small files is equal to dir dot list files, and the parameter, okay, we write a lambda. Yeah, tell me now.
Length was it?
Mhm.
Length. No, sorry. Less than.
Huh. Less than 1024.
तो पहले उसका वेरिएबल कुछ भी होगा जो भी.
Okay. Okay. Want to write a block now?
Yes.
Okay. So you want a file object? Fine, you'll have to do something like this. File f equals that way, right?
Yes.
And then you'll be saying new file created from d comma fn. Fine. And then you might say return f dot length less than maybe there's one more bracket. Yeah. Fine. See, we had to take that additional step of combining the two to create a file object. Instead, if we had used a file filter, that step would go away. See, what is the difference? File name filter and file filter. I'll say, okay. So now we can use, let's use a file filter. So same thing, I'll say a small files equals dir.list files parameter, given a f, fine, okay, let me f dot length less than 1024. Done.
So the D और F same नहीं होगा?
Huh? Which D and F?
ऊपर वाला है जो
Huh. Here
OD
directory and a file name in that directory. And first is a file object, which is the directory, which is for the directory in which that file exists, which is giving the file name. So it has separated the two, right? A directory and a file name within the directory. And then what we had to do was, we had to create a file object to combine the two, to create a file object for the file in that directory. But in case of a file filter, the file in the directory is straight away given as a file object. Okay, so that's more convenient. File filter would be more convenient. See, file name filter was convenient in the first case because our criteria was based on something which is related to the file name. And it's about the file name. The criteria was about the names of the file has to be ending in .java. Fine. The second parameter is what we were working on. But if we have something which is about the information about the file itself, other than the file name, okay, fine. Then
sir इधर D dot length less than 1024 करते हैं.
D is the directory.
सर वो भी फाइल ही है.
Yeah, but it is which file? It is the file object to represent the directory.
एक डायरेक्टरी में मल्टीपल फाइल्स हो सकते हैं.
So what is the length of the directory? Is it that we are interested in, or the file being listed?
So दोनों फाइल ऑब्जेक्ट ही है ना, D और F दोनों.
Here this is file object. Okay, let me explain like this. You have the folder which is the bin folder, right? So on the bin folder, for the bin folder you have created a file object. So I have a file object dir equals, okay, something for a particular folder, right? You have created a file, sorry, it's a new file which you have created by specifying a folder. Fine. When we use these two parameters, what is D?
Path of directory.
It's a dir. It's the same object as the dir. And fn is the name of the file in the directory. And then what we had to do was, we created a file object by combining the two. That means we created the file objects for each of the file in that directory. What we have in the second is, we are using a file filter. Instead of file name filter, this is, we are applying a file filter. What is file filter giving me? A file object which has already combined the two things. Fine. So if I am looking at dir d.length, what am I looking at? I am looking at the size for the directory. My interest is size for the file. Fine, which is inside that directory. So this is a file inside that directory. Fine.
So ये directory का भी type file है इसलिए कर-
हाँ, file, हाँ, the type is file. That's correct. The type is file, but a different object. Fine. Anyway, there are lots and lots of other methods also, and there are some more methods in the file class. Okay. We have method to even create a new directory. You want to create a new directory. So on a file object which is representing some path, and if it is not existing, fine. So it has a method to return Boolean. Name of the method is mkdir, no parameters. We even have mkdirs. There are two different methods, mkdir and mkdirs. Make directory or make directories. Okay. The difference here is, maybe you have a file object. Let me just consider that someone gives a very different name and says, oh, I have a path of /abc/xyz. Okay, so if that's my path and ABC doesn't exist, if ABC doesn't exist and I say, oh, create that path for me, and if I use this first method, it's going to say false. We can't create this because ABC doesn't exist. You can't be creating XYZ under ABC. Fine. But if I use mkdirs, what will be done? It will create ABC and it will also create XYZ under ABC. Make directories. Fine. So if the previous directory labels are not existing, or they all can be created. With make directories. But if the thing already exists, right? If it is existing directory, or this is going to say false. You can't again create it. Okay, there is a file and you want to rename to a different name. we have a method called rename2, which has a parameter which is again another file, which is, you can say, destination, the new name you want, right? So this also returns a boolean, rename2. This can result in moving a file from one directory to another directory also. Fine. So there is one path, and you got
फाइल का नाम नहीं देंगे,
file,
उसको change
you are doing it on, this method is an object of file. That's the source, right? You are invoking this method on a file object, that is the source. And it's assumed that what you are calling on, the file object on which you are calling, is an existing file object. After this call, if it is successful, that won't exist. The new thing would exist. What you are passing as destination must not be an existing thing. This should not already exist. Okay?
सर तो ये डायरेक्टरी हो सकती है या फाइल हो सकती है, दोनों में से कोई भी.
This is the one which you are passing? Yeah, on what you are calling? If it's a directory, it remains as a directory. If it's a file, it remains as a file, but with a new path, at a new path. Name or could be path.
अगर डायरेक्टरी
It has got moved. You have some path, fine, by which this file is or directory is being identified. It's stored at this particular path. Okay, and what you have given is another path altogether. What was available with this path will become available with this path, and this path won't be available. Fine. This was to be converted to this.
rename2 के अंदर ये आर्गुमेंट है.
Yeah, this dot rename to, and you are giving the other argument. You are invoking on an object, right? That object is a path, and you are changing to a different path. And the destination path you are mentioning is a non-existing one. It shouldn't exist.
बहुत सारी मेथड.
इसमें तो कुछ वैसा नहीं है,
Huh?
सारा सामने है, बाकी का पीछे में तो नहीं तो
ये लग रहा है कि आसान है.
Anyway,
इसको PTI को कितना पूरा
fine.
100
Make directory, huh?
सर हमारे बैंक में
Exists we'll be able to use, right? We might be using, I don't know, we don't using length or rename to such things.
लेकिन सर
हमारे बैंक में we are going to use the IO part more, but exists तो use हो ही जाता है सब checking करने के लिए, if it exists or not.
डेटाबेस और
His
फाइल
directory
का
is high,
पाथ
and we can have a small exercise.
है. डेटाबेस और फाइल में
Database is what? It's a relational database. You have got tables.
मतलब सर वो
That's a different concept. Files are the physical files. Fine. Like you have a file, you may have lot of text files, and you may have a binary file. You have got file which has a picture. Fine. It's an image file. Audio file. You have a file which is a plain text file. A Java file is a text file.
सर मैंने एक वीडियो देखा था, उसमें ऐसा कहा कि स्टार्टिंग में जावा 1.0 से 1.4 तक फाइल पॉपुलर था, 1.4 या 1.2. बाद में वो फाइल निकल गया और डेटाबेस पॉपुलर हो गया, बाद में फाइल वापस आया, ऐसा बोल रहा था वो।
कौन है ये?
डेटाबेस का कॉन्सेप्ट
ये ऐसा कौन है, ऐसा घुमा रहा है? कुछ भी फंडा दे रहे हैं।
पता है सर?
क्योंकि
उसके वीडियो यूट्यूब पे
मैं एक बार देखने का ट्राई किया था थोड़े दिन पहले, उसने बोला था तो मैंने देखा। वो रिपीटर है पूरा, रिपीटर की तरह से बोलता है।
हाँ, 1.75 स्पीड कर दी,
हैं?
1.75 टाइम्स फास्ट दिखता स्पीड आती है ना।
पर स्पीड में वो एक ही सेंटेंस 5 बार बोलता है।